Have you ever wondered how ancient Roman structures, like the Pantheon and the Colosseum, have stood for over 2,000 years, while many modern buildings start to crumble after just a few decades? The secret lies in their revolutionary building material, Roman concrete. It's not just old. In many ways, it's better than what we use today. So, what made it so special? And why don't we use this super concrete anymore? Let's travel back in time. For centuries, historians and engineers were baffled by the incredible durability of Roman concrete. Structures submerged in the harsh, salty sea for millennia, like the piers at Caesarea, are still remarkably intact. Modern concrete, in contrast, would erode and fall apart in the same environment within 50 years. This isn't just a fluke. The Romans engineered their concrete to last. The key ingredients were volcanic ash, lime, and seawater. Specifically, they used a type of volcanic ash called pozzolana, which they found in abundance near Naples. When they mixed this ash with lime and water, a powerful chemical reaction took place. This reaction formed an incredibly stable and non-corrosive binder, essentially gluing the aggregathous small stones and pieces of rock together into a rock-solid mass. This was a monumental leap forward from the simple mortar mixes used before. But the real magic, something scientists only recently uncovered, is its ability to sell. For years, researchers noticed small, white chunks, called lime clasts, embedded within the concrete. They were often dismissed as signs of sloppy mixing, but a recent study revealed these weren't a mistake at all. They were a deliberate design feature. When tiny cracks form in the concrete, whether from stress or seismic activity, rainwater or groundwater seeps in. This water activates the lime clasts, triggering a new chemical reaction. The lime recrystallizes and fills the cracks, effectively healing the damage before it can spread. It's like the concrete has its own built-in repair system, constantly strengthening itself over time. Modern concrete just doesn't do that. Once a crack forms, it's a pathway for water and chemicals to get in and corrode the steel rebar, leading to structural failure. So, if Roman concrete is this incredible, self-healing super material, why on earth did we stop using it? The answer is a combination of history, convenience, and cost. After the fall of the Western Roman Empire around the 5th century, Europe entered a period of instability. The vast trade networks that moved materials like pozzolanic ash collapsed. The sophisticated engineering knowledge was lost, and recipes for this amazing concrete vanished for over 1,000 years. When concrete was reinvented in the 18th century, the world was a different place. The Industrial Revolution demanded speed and standardization. Modern Portland cement was developed, and it had one huge advantage. It cures incredibly quickly, sometimes within hours. Roman concrete takes weeks, even months, to fully harden. In today's fast-paced construction industry, time is money. Builders need to put up skyscrapers and bridges on tight schedules, and waiting for concrete to slowly cure just isn't practical. Furthermore, the key ingredient, volcanic ash, isn't readily available everywhere in the world, making it more expensive to source and transport than the limestone and clay used for Portland cement. However, the story doesn't end there. As we face growing environmental concerns, Portland cement production is responsible for about 8% of global emissions. Scientists are looking back to the Romans for inspiration. Researchers are now developing new, eco-friendly concrete mixes that mimic the chemistry of the ancient recipe. They hope to create a modern material with the longevity and self-healing properties of Roman concrete, but with the fast-curing convenience we need today. The enduring legacy of Roman engineering might just hold the key to building a more sustainable future. Thanks for watching. If you found this interesting, do not forget to like this video and subscribe for more deep dives into the amazing technologies of the ancient world. See you next time.